Oh well, right. So I forgot to record, but here we are. So this is Pascal's triangle, and we can use Pascal's triangle to help us expand these binomials and even more crazy ones than just x plus 1. Okay, so we're going to use Pascal's triangle to help us expand something a little more interesting. All right. So we're going to use Pascal's triangle. This is the binomial we want to expand, 3a plus 2b to the 4th power. Before we do this, I'm going to write down Pascal's triangle. So we're going to go through that pattern one more time, okay? So Pascal's triangle starts with a 1. And the reason it starts with a 1 is because x to a power of 0 equals 1, okay? And so on this, that's why we start there, because it starts with the power of 0. Then we bring down the 1s on either side. What's the next line? 1, 2, 1. Very good. What's the next line?
3, 3, 1.
1, 3, 3, 1. All right, next.
1, 4, 6, 4, 1.
Good, because 1 and 3 makes 4. 6, because 3 and 3 makes 6. And 4 and 1. And then what?
1, 5, 10, 10, 5,
1. Good. One more.
1, 6, 15, 20, 15, 6, 1.
Good. Okay. All right, so here we have Pascal's triangle, and what we want to understand is which line we use. So the problem that we're going to work on has a power of 4. That first problem had a power of 4. Is that correct? Yes. Okay. So this first line we would use if we have a power equal to 0. The second line is power equal to 1, power equal to 2. Here's our power equal to 3, and power equal to 4. So it really starts counting at 0. And so I'm going to look at that power equal to 4 line, and that's telling me my coefficients 1, 4, 6, 4, 1. So I'm going to go ahead and write that down here. And you're going to need a lot of space here. I might run out of space. What were those? 1, 4, 6, 4, 1. Give yourself space in between. 1, 4, 6, 4, and 1. Lots of space there. Those are the coefficients. And from that point, what I'd like to show you is, you'll notice when we did this first one, it starts out where we're taking that x, and our first term is the x to that highest power, whatever our power was. All right, so that first term in the binomial, in this case, is the 3a. Oh, I'm going to use a different color. I'm going to use green. So I'm going to take that first term, whatever it happens to be, and I'm going to give it that highest power for. So I'm going to take that 3a to the 4th power. Then you'll notice what happens to those powers on that first term x. It starts with the highest power, and then what do those powers do? They go down each time. And so we're going to do the same thing. So I'm going to take my leading term, 3a, and I'm going to just walk those powers down. So powers down, 4, 3, 3a squared, 3a to the first, and 3a to the 0. Those powers just walk right down. And then it turns out that something happens to the second term as well. And those, you can't really tell on the problem that we did, but we're going to sort of do the opposite. We're going to walk those powers up. So I'm going to take 2b and just walk those powers up. So 0, starting at 0, and 2b to the first power, and 2b to the second power, and 2b to the third power, and then 2b to the 4th power. So I like to just say powers down, powers up. That's sort of what happens. So count your powers down, and then count that second term, powers up. All right. If there was a sign like a negative in front, you'd want to include that sign. And so you might have some sign changes. I'm just going to go ahead and put pluses in between all those. And then from there, I just have to do a little bit of multiplying. What happens with 2b quantity to the 0? It's 1, so that goes away. That's nice. And I'm left with 3a quantity to the 4th. What does that mean? There's 4 of them. 3a times 3a times 3a times 3a. Very good. There is 4 of them. And what would that give you if you multiplied that? 3 to the 4th is 81. Yeah, 81a to the 4th. And times the 1 is still just 81. Here I have, I might need to do some calculator work here. 4 times 3a quantity cubed. What is that? 27a cubed. Very good. And then 2b to the 1st is 2b. I'm going to have to clean that up a little bit. I'm definitely going to need a calculator for that. I really don't want to multiply that in my head.
162.
It's 162. Damn, son. 216. How about 216? All right, so 4 times 27 times 2 is 216. A to the 3rd times b. You good? All right. Then my 3rd term here, I have 6 times 3a quantity squared is what? 9a squared. And then 2b quantity squared is 4b squared. And if I want to clean that up, 54 times 4 is 216. How about that? 216 a squared times b squared. Are you guys good so far? It's weird, right? It's a weird process. We'll do another one so you can play with those powers some more. God bless you.
Thank you.
Here we have 4 times 3a. And what's 2b quantity cubed? What is it? 8b cubed. Good. 2 times 2 times 2 is 8b cubed. It's 96. 4 times 3 times 8 is 96 times a times b cubed for that term. And then the very last one, what's 3a to the power of 0? 1. And so I'm just left with 1 times 2b quantity to the 4th. 16b to the 4th. Good. 2 to the 4th is 16. So that's just 16b to the 4th. Weird process, right? But it works every time. And that's kind of neat. All right? All right, let's try one more of those. Just so you can see how this other one would work. 2x plus 3y to the 5th power. So this is my power equal to 5. Maybe it's fun. You get to do some of these in your homework too. All right, so I'm going to look at my Pascal's triangle. And what line should I use? Yeah, right here. 1, 5, 10, 10, 5, 1. All right, I'm going to spread that out down here because actually I might need more room than that. So here we go. 1, what was it? 1, 5, 10, 10, 5, 1. Okay. I'm just going to put some pluses in front of those. There we go. All right, so there's my coefficient multiplier, scalar multipliers. And I'm just going to take my leading term in my binomial, and what happens to it? It's 2x quantity to the fifth, and then what happens with those powers? They count down, so 2x quantity to the fourth, and 2x quantity cubed, and 2x quantity squared, and 2x to the first. And do I need to write 2x to the 0? No, it's just 1, so I don't have to write it, but you certainly can. All right. And then I'm going to take my last term in my binomial, and what am I going to do with those powers? Count them up, starting at 0. So 3y to a power of 0. Do I have to write that one? No, yeah, you could leave it off. 3y to the first, and then 3y to the second, and 3y cubed, 3y to the fourth, and last 3y quantity to the fifth. So really, just the powers down, powers up is that's easy to do, right? It's the multiplying that gets harder, but believe me, it's easier than having to multiply 5 bubbles together. All right. All right. So nice for that respect. What is 2 to the fifth? 32. So 32x to the fifth times, 1. 2 to the fifth. And that's just going to be 32x to the fifth. And again, you might want a calculator. All right, we got 5 times, what's 2x to the fourth power? Quantity to the fourth. 16, x to the fourth, good. And then we also have the times 3y. And 5 times 16 times, 5 times 16 times 3. 240, good. X to the fourth, y. This is fun stuff. All right, here we have 10 times, what is 2x quantity cubed? 8x cubed. And 3y quantity squared is?
What?
3y quantity squared is 9y squared. And 9 times 8 is 72 times 10, I guess 720. Look at that math there. Y'all okay over there? Yeah, okay. Here we have 10 times, what's 2y quantity squared? Sorry, 2x quantity squared. 4x squared. And then 3y quantity cubed? 27y cubed. Very good. 3 times 3 times 3 is 27y cubed. 10 times 4 times 27, 1080. X squared y cubed. Five times 2x times, what is 3y quantity to the fourth? 81y to the fourth. Very good. I guess that'd be 5 times 2 is 10 times 81. 810. Now what's 3y quantity to the fifth? 3 to the fifth? Very good. 243. So 243y to the fifth. It seems exhaustive, but it's kind of a cool thing. And like I said, I would rather do that than have to multiply 2x plus 3y times 2x plus 3y. And so all right, ladies and gentlemen, do you have more questions for me? Other than do we have to do this? Okay?
Okay.
All right.